Hello students. Today we're going to talk about simple data in Python. Information in Python can be broken down into a number of different classifications. The simplest of these is a value. A value represents a single chunk of data, a piece of text, a number, or a special data object. Every piece of data in Python is considered to be an object. Objects are classified by their data type, which is also called a class. Some examples might be integers, strings of text, and floats, floating point numbers. The class of an object determines what properties that object has and what behaviors it has, what sorts of functions we can use with it. The type function can be used to determine the data type of an object. There are also special functions that allow you to translate objects between types. These are called type conversion functions. For example, the str function translates an object into a string. The int function translates an object into an integer, and the float function translates an object into a floating point or decimal number. Again, because the type of an object determines what properties that object has, and what behaviors that object can undertake, it's important to make sure that it's in the right type. For example, if we have a string of numbers, say we have the string 548, this is a piece of text, and if we try and do mathematical operations on it, we'll get some interesting and unexpected behaviors. However, if we turn it into an integer first using the int function, then we can perform mathematical operations on it and get the behaviors we expect. Variables are names that refer to an object. Names can be any string, but must begin with a letter or an underscore and cannot include spaces or some other special characters. And we use assignment statements to assign a variable to an object. For example, we can use the statement x equals 10. This creates the variable x and assigns it to the object, which is the integer 10. The assignment operator is a single equal sign. The variable name must be on the left and the object or value must be on the right. It's worth noting that a variable can only reference one value at a time. For example, if we say that x equals 7, and then on another line say x equals 12, when we print x, we'll only see the value 12. Once we overwrite the value that's stored in the variable x, we lose the original value. Variables are how we tell the computer to remember things. Whenever we have a piece of data that we want to keep track of and use later on in the program, we can create a variable to store it and then reference that variable later to make sure that that piece of data stays available to us. It's worth noting that this is a little different from how we use variables in mathematics. Often in math you'll say y equals 7x. And then for some value of x, you can compute y. This isn't how we use variables in Python. Instead, you can think of a variable as a storage box that you can put some piece of data in or some piece of information in. One thing to note on names is that while they can begin with any letter, lowercase is traditional. We usually use lowercase letters to refer to variable names, function names, and then uppercase letters as the starting letter of class names. So for example, the int class starts with an uppercase I. There are some other conventions you might see. For example, beginning the variable names for variables that contain integers with a lowercase I. Or when we create a constant variable, a variable that we simply use as a name so that we can refer to it by that name, it might be in all capital letters. An example of this might be pi or e, the mathematical values that are unchanging. In a program, a single line of code is called a statement. We've seen several types of statements, notably the print and assignment statements. Other statements have more complex roles in a program. Some examples are while, import, if, and for. Each of these statements has a different purpose, and many of these actually occur on, or rather create what's called a code block, which can contain many additional lines of code. An expression can be any combination of values and variables, as well as operators and function calls that evaluate to a single value. Expressions are evaluated when the program is run. For example, if we say x equals 7 and y equals 12, then when we run the program and we try and print out an equation involving these variables, we'll be able to compute and see the result of that equation. Operators are special symbols that cause Python to do something. We've seen the assignment operator, the single equal sign that allows us to assign a value to a variable. The most common operators we'll see are mathematical operators. There are also logical operators, but we'll cover those more in a later chapter. The common mathematical operators you see are addition, subtraction, multiplication, division, the power operator, integer division, and the modulo operator. Now there's two here that you may not be familiar with, integer division and modulo. Integer division only returns the whole part of a division operation. So for example, if we were to say 7 divided by 3, the answer is 2 1/3. But if we did integer division, we would only get the whole part of that, which is 2. The modulo operator is another interesting operator, and it returns the remainder part of a division operation. So if we use that same example, 7 divided by 3, we might say that it has 2 remainder 1. So if we were to say 7 mod 3, which is the percentage sign, then we would get the resulting remainder, which is 1. The order of operations is as it is in mathematics. The power operator has the highest precedent. It's the first operator to be evaluated in a statement. Then we have multiplication, division, integer division, and modulo operators. These are all evaluated left to right in the order they appear. After all of those operators have been completed, we see the addition and subtraction operators be evaluated. One thing to note is that variables can be updated to reflect a change in their current value. This is because the assignment operator reads right to left, in the reverse from what we're used to. The right-hand side of the operator is always evaluated first. If you look at this code fragment, we can see that the variable myValue is set equal to the number 10. On the next line of code, we actually take whatever piece of data is stored in myValue, in this case 10, and we add 5 to it. And then we store the result of that operation in the myValue variable. We can then use a print statement to determine the contents of myValue and see that it's 15. Because the assignment operator reads right to left, we can use this to update the value of a variable with new information that we gain as our program executes.